Greetings! Welcome back from break. Happy Monday if you're watching this on Monday. My name is Miss Tiberio. I teach 6th grade science at Jane Addams Middle School in Seattle, Washington. I'm here to help you with the weather patterns unit. So what are you going to need today? Today you're going to need something to write with and something to write on, or the packet if you have the packet. You can pick the packet up at lunch drops, places where they're distributing food. You can get the packet from the Schoology page that your teacher's probably set up for science and print it off. You can also find these packets on the Seattle Public Schools website. So this packet is a really handy tool to go along with the video, but if for some reason you don't have the packet, that's okay. Just have something to write with. I'm going to project the packet on the screen, and you can write along with us. All right, so I'm going to wait while you get your stuff. All right, got it? Great. Here we go. All right, our weather patterns packet looks like this. This is the one we're working on this week. We're going to finish chapter 1. We're going to do a little check our knowledge this week, and we are going to start chapter 2. So this packet's going to have a little introduction page to families. You can read that later. This is our plan for the week. Today is day 1, and we're going to do chapter 1, lesson 1.5, investigating why clouds produce rain. So our warm-up today, remembering back. We read the article, What Are Clouds?, before we went on break. What do you remember about how clouds form? What do I remember about how clouds form? Sometimes I don't really remember every single thing that I've read, which is why we annotate. So if you don't remember, it's okay if you go back and look at the article. So I'm going to pull up the article so we can take a quick peek at it together and write some things down. Okay, here's the article. It had these fun pictures of all these different cloud formations. It's called What Are Clouds? It talked about this scientist who was fascinated by clouds when she was little and grew up to study them. It talked about what do all clouds share? Things about water vapor and temperature I found important. There's this whole section on cloud formation and energy we're going to come back to. All right. So now we're going to take a minute to write some stuff down. So I'll wait for you to write your thoughts down, or you can pause this video if you need more time. Okay. Let's review our vocabulary so far. So in the packet, you can see that we have a variety of vocabulary terms that we should all be familiar with at this point. Air parcel, condensation, energy, evaporation, temperature, transfer, water vapor, and weather. Some of these words we learned in this unit, and some of these words we learned back when we did the thermal energy unit. So today our goal is going to be answering the questions, what makes an air parcel cool? And how does the energy change relate to the amount of rain that will fall from the cloud? So how are we going to do that? We are going to collect some data from the sim, and we're going to refer back to the article that we started using just a little bit ago for our warm-up. And we're going to define clouds. Okay, our definition of cloud is liquid water droplets suspended in the air. Yes? Great. So, moving on in the packet. Let's think back to the activity we did about several days ago now about the plastic Ziploc bags that we blew into. We put our breath in it, we sealed it, We put one of them on the counter and we put one of them in the refrigerator. Do you remember that activity? I hope you got a chance to do it because it was really cool. Which bag do you remember having more condensation? And condensation would be little drops of water that you would see on the plastic inside the bag. Do you remember which one had more? Mine had more when I put it in the fridge. When it was in a colder area, more droplets were present than when it was just out on the counter. Do you know why? If you already know why, yay, congratulations. If you don't, we're going to work on figuring out that answer today. So to do that, we're going to go back to that article and look at cloud formation and energy, because that is going to help us really answer the question, what causes an air particle to cool? Okay, ta-da, here it is, cloud formation and energy. So what I notice in here that I think is important is kind of right in this area. When a warm air particle is surrounded by colder air, the energy from the warm air particle is transferred out to the colder air until the temperature of all the air is equal. While an air particle is losing energy, the temperature of the air particle decreases. The energy transfer that causes the warm air particle to cool can also cause the water vapor in the particle to condense into a liquid. This liquid water is what forms a cloud. The more energy the air particle loses, the more it cools, and the more liquid water it forms, making rainfall possible. When the droplets of liquid water in the cloud become big enough, they fall to the ground as rain. Great. Okay, so based on that section and what I just read, what evidence can you find to help us answer the question, what causes an air particle to cool? Take a minute, write some thoughts down. All right, you can always pause this video and write. You can write while listening to the next section if that works for you. The next thing that we're going to do is we're going to go into the sim and we're going to gather some evidence there. If you have access to Amplify, then I highly suggest that you pause this video and you go play around in Amplify and you fill out the sections in the packet, and then you come back and watch the video and see if you got it right. But if you don't have access to the sim, that's okay because we're going to do it together. Okay, this is what the sim looks like. It has areas up here, my cursor, for building, for running, for analyzing, and then we have the space in the center that's showing us what's going on. So this is our air particle. This is our surrounding air. This is where we can adjust our water vapor. This is where we can adjust our temperature. And in your packet, if you have your packet, there's a table, right? Ta-da! There's a table that you can fill out the information that we're going to collect while we're doing the sim. Okay, this is what the table looks like. So this is where you're going to be recording your data. We are going to go into the sim and we're going to build, and we're going to set the air temperature in the air particle to the numbers that you see here. So negative 20 degrees Celsius is what the surrounding air is going to be, and 25 is what the air particle is going to be. Okay, so I've got 25 up here. I have 25 in here, but wait, this is supposed to be 20, so I'm going to change it. All right, it's a little particular. Let's see if we can get it on 20. There we go. And then I'm going to change the water vapor to sort of a medium-high level, because that's what it's calling for on our table. And now I'm going to turn this to run, and we're going to see what happens. All right, I'm watching. What do I observe? I see some rain. How did that happen? Okay, let's try that again. So negative 20, 25 here, medium high here. Let's run it again. Okay, I see some energy going out. The yellow arrows are telling me energy's going out. I see the air parcel temperature and the surrounding air temperature are now at the same place. They're both at -20, and I see some liquid water has fallen in the form of rain. All right, let's see what this analyze function does. All right, over here, I see the information about the starting temperature, the final temperature, the difference in temperature. I see that some energy transferred out, and that's measured right here. I see information about water. I see total amount of water, and then it's talking about all the different forms. Water vapor, liquid water, that's the cloud, and then liquid water, that's the rain. And then down here, it's telling me what the rainfall level is. This cloud produced a rainfall level of 1, so there was just some water, but we can go all the way up to 4, which I'm imagining is like a pretty big storm. Okay, so hopefully you've recorded your data in the table, and I want to point out this bonus sim activity, so you can go back in on your own time, and you can build using these same conditions, but changing the water vapor level. So in science, it's always a really good idea to run multiple tests so we have multiple data points. So we could run the water vapor at low, medium, and high, and that would produce a different rainfall level, possibly. But we'd need to run the test to find out. And then we could answer the question, how did the amount of surface water affect the amount of water vapor in the air? So you can go and do that on your own time and see what you come up with. Okay, so let's wrap up our lesson. So what have we talked about today? We were trying to answer some questions. We were trying to answer what happens and how does an air parcel cool, what's going on there. And we've discovered that it cools as the result of an energy transfer. We have also been looking at how does temperature and the amount of surface water affect the amount of water vapor, and how does that impact rain. So our sim exploration hopefully helped you figure that out. Yeah? If you went and did those extra sim tests, those bonus sim exercises, I bet you found out even more information. That brings us to our key concept. Energy transfers from warm air to cold air until the temperatures become equal. We saw that in the sim. We also probably remember that from thermal energy, right? Energy transfers from hot to cold. Another key concept that we just talked about, the more an air parcel loses energy and cools, the more rainfall can happen. So bigger energy shift from the air parcel on the inside to the surrounding energy on the outside impacts the amount of rain that's going to fall. And then you might have also found some information about water vapor, and if you've got a lot of water vapor, or if you just have a little water vapor, maybe you get more or less rain. We're going to learn more about water vapor in the next lesson. So what's coming up next time we're together? We're going to evaluate some claims about what is causing severe rainstorms. We're going to look at some data, and we're going to practice our CER skills, our claim evidence reasoning skills. We're going to do some writing. All right? So I look forward to seeing you guys for our next lesson together. If you didn't have time to write down everything in the packet during this video, that's okay. You can pause the video, you can rewatch the video, you can take a few minutes to summarize your thoughts. Thanks for joining me. I'll see you next time.